Three, two, one, and we are live. Hello, everyone. Welcome to 345 Tech Talks. I'm Andrew. I'm a partner of 345, and I'm the CEO of Glue, which is the big project we've got on. I've got with me Paul Brown. Paul is another partner of 345, and he is sort of CTO, Chief Engineer of Glue. And we're going to talk about today's topic, which is if I can bring up my slide. We're supposed to be slick on this, but it is Friday. So I brought up my slide: how to rapidly deliver a Kubernetes microservices platform, which is a bit of a mouthful. We've talked a lot recently about many really relevant things. So we talked about microservices, debugging microservices, and we've talked a lot about DevOps and the DevOps stack that we've got, and we've talked a lot about Kubernetes and all the amazing things about Kubernetes. So what we're trying to do in this episode is to bring a lot of that together, so that actually, I try to think of it from the perspective of, so let's say you're out there and you really want to push out software quickly. You've realized microservices is a great thing. You want microservices, cloud, containers, all that sort of stuff. You've bought it now. You know that's what you want. And let's say you're a CTO or you're a chief architect or something like that, and you say, right, I want one of those right now. How do you go about it? Yeah, we've kind of talked about tons of stuff at the quite a detailed level, but really, if you want to start and roll this stuff out and get all the benefits of a Kubernetes microservices platform and get that into your organization really quickly, how do you go about it? And that's kind of the perspective we're looking at today. So really just, this is okay, we've talked a lot about all this stuff. Let's get this stuff hitting the road, because we've done this quite a number of times now in different ways. We've been doing cloud for many years. We've been doing Kubernetes for several years, and Docker for several years. We've been doing NoSQL for years. We've done this for our own projects. We've done this for our own websites, for our own APIs, and we've done this for and we've done this for clients of 345. So we've been around this roop. What's a roop? We've been around this loop many times now, and so we've we've kind of tried to distill some of the learning from that into an approach that we use regularly. So that is the subject of today's podcast. And just as a reminder, one of the specifically, we're talking about the most recent iteration that we did, which was for Glue, which is our new venture, Glue, TripAdvisor, the encyclopedia and TripAdvisor of cryptocurrencies. If you find yourself lost on Planet Crypto, let us be your guide. Launching at the end of April with a live beta, and more features rolling out all the time after that. Really exciting project. But the technology, from a consumer's point of view, it's really exciting. From a technology point of view, it's really exciting as well. So that is really a lot of the learnings that we're talking about on this podcast are coming from that. And the other thing we talk about is the 7 outcomes. So, how can you know what success is? How can you achieve success if you haven't first defined what success is? And this is where the 7 outcomes come in, because that gives us a broad measure of success. So the 7 outcomes are rapid delivery, quality bug-free, available and scalable, secure, functional and lovable, costs are optimized, and we are compliant with all the standards we need to be compliant with. Now, when we talk about Kubernetes, and I've highlighted some of them in, Paul may or may not think that they're all appropriate, but taking this, the holistic thing of microservices platform, use a microservices platform built in Kubernetes. I mean, one of the things, so we're definitely interested, we're definitely helping with rapid delivery. I think we're also helping with quality and bug-free, because the microservices and the whole way we DevOps that up and that sort of thing, I think helps with that. just the whole infrastructure platform of Kubernetes and microservices helps you achieve that quality. It does mean we're available and scalable, because one of the big things about Kubernetes is it's a technology for making sure that you've got availability across clusters. I think we also help with security. I mean, particularly we're looking at the DevOps side of it and the hosting, so we can really make sure that by following this infrastructure approach and this DevOps approach, we stop having operators fiddling with our systems, which means that by default they are more secure because there's less manual intervention. We don't particularly touch on functional lovable. That's up for you. That's for you, and that's what you put in your apps, really. We're not going to, we can lead the horse to water, but we can't produce the functional lovable drink.
We can't. Yeah, we can't make it drink it.
Yeah. But yeah, we can get you as close as possible, so that because the idea is, and we said this before, that by doing all this, the thing with doing the DevOps and by doing the proper platform, Kubernetes platform, we're taking away all the stuff that used to consume a whole ton of people's time. We're taking that away and making that easy so that you can focus on things like functional lovable, because that's where the differentiation for your organization, for your business is. What makes your business different from anyone else is what you should be focusing on. So what we're trying to do here is almost like we're trying to tick all the other boxes so that you're freed up to deliver what makes a difference for your business. I've got costs are optimized. That's ticked because with Kubernetes we can get a very dense hosting model and really efficient hosting of our apps and deliver them in a very cost efficient way from a development perspective. And I had a question mark over standards compliant because it's partly, but it's not guaranteed. It's I mean, our approach will help with a lot of the InfoSec kind of an operational sides of meeting standards, but there's still the functional sides of meeting standards. So I've got a question mark over that one.
Yeah, I mean, it depends on whether you need to be compliant with anything. Generally speaking, if you're in the EU, probably GDPR at the very least, or e-privacy as well.
Yeah.
But it depends on the platform you pick. So the cloud platform also has to be compliant, but your application as well and your processes.
Yeah.
So it's going to be some of what the platform gives you, and also some of what you actually need to do yourself. And not that we can say what you absolutely need to do there, because it's very much dependent on each individual situation.
Yeah, absolutely. So in terms of going through this, so what we're talking about is, if like I say, if you wake up this morning, put the podcast on and think, holy moly, I need one of those microservices platforms. We've got effectively almost like a delivery plan that you can lean on, that we're going to talk through. So you don't have to need any of our IP to get something out of this podcast, but at the same time, if you want to get even quicker, then get in touch and we can send you the white paper and talk about it. But we're generally talking about 4 phases. So the first one is the definition phase, when we actually just firm up exactly what it is you want. We've got our blueprint for what we think you need, or what we think a generic organization would need, but everyone's got their own particular flavors on top of that, so we have to sort of just pin down those things. Then we go into actually delivery, so delivering the infrastructure platform, delivering the technology platform, and by delivering that, what we then have is something that app teams can then rapidly deploy onto. And then we go into the exploit phase, where obviously we're trying to make sure that app teams can accelerate and take advantage of the fact they've got this infrastructure platform. and then over at the top of that, what we're going to talk about at the end is the is maintaining that, what sort of things you need to think about to make sure that that platform stays up to date, stays relevant, and stays in good shape. So those that's kind of framing the discussion really for the start. So
Yeah, I think it's worth pointing out that we talk about technology platform with Kubernetes and cloud and stuff like that, but it's this talk is very much about the sort of organizational aspects to it as well. It's not purely about technology.
yeah, so the technology platform is the result, but it's not the
exactly. Yeah,
but we're talking about how you get there.
Exactly.
And a kind of a tried and tested approach to getting you there. So the end result being that you've got app teams that can exploit a technology platform. That's the end result. That's not, so we're not describing the end result. We're describing the journey.
Yeah.
Absolutely. So let's start with the first part then. So as with any project, the first thing you do in the project is actually say, what is it we're going to do? Which may sound like the bleeding obvious, but it's still, even in this day and age, amazing how many people jump in with both feet and just say, hey, let's start a project. Oh, we've built all this stuff. Oh, we've spent all this money. What is it we're doing again?
Yeah.
And so,
the definition phase, as you say, is really important.
Yeah, and it doesn't have to be long.
No, exactly. And people that are of an agile mindset will probably think, oh my God, this is requirements, right? Requirements gathering and whole analytical phase that lasts years. It's not really, but you've got to have some idea of what it is that you that you want before you can actually really embark on this journey. And it is the definition phase, but it's discovery.
Yeah, I like that term, discovery. But it is very much, and so the first thing we need to do is we need to pin down the scope, and again, it doesn't have to be a big thing, but like say if you're an organization CTO or you're a chief architect, and you will basically, if you're having this discussion with us, the first thing you'd say is, well, I use this, we've already got a source controller Git platform that we use. We want it to be this one. We've already got our preferred cloud vendor, which is whichever one, AWS, Azure, Google, whatever cloud platform it is. We've already got a commercial relationship with the cloud platform, so it's got to work on that one. And then you'll say, well, okay, our DevOps teams have already got preferred DevOps tooling, so whatever you do, it's going to have to work with the kind of the tooling set we've gone, etc., etc. So it's not necessarily that we need to go off on some massive wild goose chase and head scratch on this, but we do have to actually pin down. What are the sort of things would we be pinning down?
Well, you're sort of here. You're defining your sort of technical boundaries, aren't you?
Yeah.
So you're sort of, because as you say, companies don't just suddenly. Well, generally speaking, companies don't just say, look, this thing is completely brand new. Go wild. There's always going to
fill your boots.
Fill your boots. There's always going to be some level of constraint in there that says, actually, you know what, fill your boots, except for all our sources is held in GitLab or
we've got all these on-prem legacy systems that need to talk to those microservices, and we need a network pipe into there. And
exactly. So you need to understand all of that before you can actually really start to think about how do you deliver a technology platform that gives you your DevOps and the ability for people to be able to create microservices and so on. You need to first off understand what is it that people, that organizations want to keep, that they can't move away from, and then that gives you the scope to then think about, well, what is it that we need to add and what is it that we need to introduce to support that.
Yeah, and the other thing that goes with that, I mean, there's the so those are the constraints, and then there's also so there's constraints and there's goals. And typically speaking, goals, uh, one of the main goals you need to set is, okay, ultimately, like say, we're going to be delivering a platform on which you put apps. So what's the process for that in terms of, okay, you're writing apps, and a lot of this ends up mapping out onto environments. So you have, okay, an integration environment, a staged environment, a product environment. For example, those might be your minimum ones. But do you have other ones? Do you have a separate UAT environment? Do you have this? Do you have that? What is your path to live, and how do we need to support that? So those are kind of goals that we need to meet as well. And
Exactly, and it is worth reiterating that we are, we're not talking about just generally any technology platform. We are talking about a technology platform that supports organizations developing microservices. Okay.
Yeah.
And running those microservices. So we talk about Kubernetes. We think that is, very much a key technology now for being able to allow organizations to build microservices and run them.
Yeah.
So although we what we're talking about now is sort of general sort of requirement definition, it's fundamentally about delivering a technology platform that allows organizations to build and run microservices.
Yeah.
That's sort of it's sort of setting a boundary on what we're talking about. So everything that we
so you're not just talking about so really so we're focusing on that. We're not just talking about, okay, I've got this legacy app that's got this massive clustered SQL database and Oracle over there, and I've got this.
Exactly.
We're not talking about lifting and shifting that. We're talking about, okay, so let's say you've got a legacy system, a big monolithic system, and you've realized that it's becoming unworkable and uneconomic to maintain it, and you need to break it down into microservices. And so one at a time, you can break them out of that, put them in this new platform, and and run them on that basis. And it's kind of, we are talking about that.
We are, yeah.
So having done that, I mean, obviously, the first thing we do is we gather that scope, then obviously, and put that together as we'd call it a technical blueprint, which again doesn't have to be heavyweight for all the people, because we're as agile as can be, but you still have to have a blueprint of because it's almost like your apps, app delivery is agile, but to some extent you still have to have an architecture, and so that architecture is you have a blueprint for that architecture, which supports that. So okay, having we've got a blueprint, or we've got an out of the box blueprint for how this stuff looks, and given the fact that during that discovery phase we'll say, well, okay, how does that affect our our template blueprint, and so really that blueprint really is how you play back to say, okay, during discovery you said this, and this, and what that means is that what's going to be delivered looks like this, and that's the blueprint. It doesn't have to be you don't have to go to town and write a book on it, but a decent Visio diagram and a few supporting notes
exactly
at the very least,
and also understanding where there might be some unknowns in there, because we're not necessarily going to absolutely lift and shift 100% what we're doing for Glue.
Yeah.
There's always going to be variations based on what it is that we need to support within a different organization. So there's always going to be potentially unknowns, but you treat them as work packages. You treat them as part of the process.
Yeah.
You don't need to figure them out up front. You can define that in an agile way as just another task on the backlog, and deal with that going forward.
Like you say, if it's if our stuff that because we typically, as we said before, we typically use GitHub. Someone else is using GitLab or Bitbucket. You got to integrate it with it. You can. that's a task on the backlog. And and
Exactly. So it does. So the blueprint is a a broad sort of brush of this is what we think we're going to deliver for you based
yeah,
on the scope that we've defined.
yeah.
As you say, it doesn't need to be extensive to the point of taking 6 months to produce.
No, I mean, the whole discovery phase should be, you know, I would think probably 2 weeks is if you were going to almost take what we've done out of the box, then you'd probably say, okay, it's a couple of weeks, and 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 if you were going to actually have a massively bespoke one, it would be a few weeks more. But you can't. But you're trying to.
You're trying to look in the weeks bracket rather than
Yeah,
the months, and definitely not years.
yeah. I mean, if this got past 2 months, we'd be seriously asking questions about, are you going down completely the wrong route and setting, are you fundamentally setting the ground rules wrong? And it could, because this whole definition phase, it should be 2 to 4 weeks really, if your head's in the right place. And and if it's a lot longer than that, then really you should be, take a step back, take a deep breath, and maybe go with best practice rather than where you're going.
Yeah, absolutely. And it's the variations, isn't it, that's going to take time more than anything, because the core approach is, I think, translatable to any organization in terms of building a technology platform. But it's just dealing with the smaller variations, and as I say, as long as you understand what those variations are, then you can create work packages for those.
Yeah.
So you don't hold up the scoping and the definition phase effectively.
Yeah, and those definitions, those variations should be variations. They shouldn't be like massive schisms.
Yeah, exactly. Yeah.
Yeah, that if you're going to use, Jenkins rather than something else or whatever, that's a variation. Does the same thing, but it's a different flavor.
Yeah.
That's a variation, but it's not like actually we're going to rip all that out and replace it with some hokey thing that we've got in the back room that no one understands.
We've decided we're not going to use Kubernetes. We're going to use an IBM mainframe from 20 years ago
to host containers.
Yeah, and it's like, what?
Yeah, no, so if you're going down that route, stop.
Yeah, if we
stop right now.
Call us.
Yeah, at that point, I'd recommend a nice cold cider, and go home early for the weekend and think about your life. So, and the last thing, obviously, from the blueprint, like I say, we then start to look at what the implementation plan is, because the more variations, the more items go on the backlog. So if if actually, so for example, if you wanted to take our blueprint and just say, yes, I'll have one of those, the implementation plan would be pretty simple. It'd be like, clone all this stuff, tweak it for whatever your stuff, tweak the bits that change, and bish bash bosh, we can pop that in. And if not, if it's not that and it's more bespoke, then obviously it's all these other things on the backlog, and get an idea for that. But like I say, in the 2 to 4 week period, we should be at the point where we've set that, we've defined what we're going to do, we've got a blueprint for it, we've got a backlog. Whether we call the backlog, it's a project management. It's a project management sort of clash of terms as to whether a backlog is a plan. But
yeah, it's. I mean, a backlog is a prioritized list of things to do, right?
Yeah, and what's a plan?
Fairly translate into a Gantt chart.
Yeah, what's a plan other than a list of things to do, and who's got to do them?
then those sorts of plans take on a life of their own and
Yeah,
become Gantt charts. And
they
I
do.
mean, you've got to have some sort of high level milestones, right? And a
Yeah,
lot of them will come out of the goals that are discovered during the scoping phase, because you can't. The customer won't say, "Oh, deliver it whenever." I can't believe. Well, I've never heard of any customer I've ever worked with saying just deliver it whenever you can. It's not. There's normally a date in there. So the implementation plan, there's going to have some milestones.
there are, and it can be quite simply. So one example of this might be that, uh, again, if you were like a CTO saying, I want to get my app teams going, the first thing might be get enough so that my app teams can start writing apps and getting them into an integration environment. And then we'll deliver a staged environment, and then we'll deliver prod, because actually this stuff isn't going to go into prod for another 9 months, but I want those guys cutting code as soon as possible. So that's one example of how you might separate out your milestones.
Yeah.
Because that is a very typical scenario.
Yeah.
So what is the so in terms of prioritizing that work, it's really what is it that gets those app teams going as quickly as possible, and that's what ultimately what we did with ours, isn't it?
Yeah, pretty much, yeah. Yeah, you can't deliver the entire technology platform in one go and then go, ta-da, there you go, you can now start using it. It's really work like that. So we've had to build the platform as we've been building the application, building the service, and by and large, it's it's been okay. I mean, there's always blockers, there's always dependencies that happen, but in an agile way, you deal with them as they come up, and you unblock as you go. Yeah. So it's very unlikely to be able to just sort of build the entire platform in one hit and then make it available to people. Chances are you're going to have this tension between the delivery of the platform and then the use of the platform, which you have to deal with, and that'll be part of the implementation plan.
Yeah. So, so the next thing, so we've got to the point now where we know what we're going to do. We know we've agreed what's going to be delivered. We've agreed the implementation plan, or you're doing this, Mr. Listener, with your team. The next part is actually is the delivery bit. Is the actual delivery of the start of that platform. So what we'll kind of talk about now is the main things. These don't necessarily have to be a strict sequence, as we said, but just the main kind of elements of how we go about delivering. So and going back to some of the principles we've had, it's everything's it's infrastructure as code. Everything is scripted. Everything is there is a single source of truth, so that we start off with the collateral, which is in which is in a source repository in Git, and from that we can always regenerate and bootstrap our environment. So we're starting really from the point of Git, and then let's talk a bit about how we start bootstrapping that.
Exactly, and then also with the mindset of automate everything.
Yep.
But automate as much as possible, right? Given the timescales in the implementation plan, which may not always allow you the luxury of automating everything, but at least going in with that mindset of automating as much as possible.
But that's why, not being funny about it, but that's why it's a really good idea to go to someone. Here's the advert. That's why it's a really good idea to go to someone like us that's got that collateral and done it, because why are you going to spend months automating everything when actually you could lift and shift a solution that's already there, where someone's I can't say this often enough, but if someone's already solved this, don't solve it again. You know what I mean? It's there is absolutely, just if someone's already solved this, just go to them and just say, how did you do it? Tell me, and then I'll do that, and you don't have to reinvent the wheel. So automate everything. Ideal thing is to just say, Okay, you guys have already got a solution for this. Can I just borrow all the automation you've already done and pop it in?
Yeah.
But because it like we've said previously on our DevOps principles episode, the automation is so important. It really is, because it's the automation that gives you consistency, it gives you repeatability. You cannot have quality without repeatability, and it frees your team from the toil
Yeah.
of
Yeah.
of doing the same thing over and over again like Groundhog Day. It gets them off the hamster wheel of manual processes
Yeah.
and gets them focusing on things that actually really add value, which is solving problems for your business. So we're bootstrapping our stuff.
Exactly. So the first thing, certainly the first thing that we did is we looked at, we need to bootstrap a DevOps environment, DevOps environment quotes.
Yeah.
Because, really, we want to make sure that we can automate everything. We know that we're going to, whenever we build a microservice, we need that to be able to be, when it's committed to the repository, to be able to be quality tested on every commit. We need it to be able to be built and then delivered to an environment. So, straight off, we know that we need a DevOps environment. So one of the first things we'd do is how do we bootstrap that?
Yep.
And part of that is what environments do we need? What environments did we define during the discovery and definition phase? Because that will effectively guide us as to what the DevOps environment needs to do. So,
Yeah.
for example, so we talk about bootstrapping the DevOps environment, but where is that DevOps environment going to live? Well, our DevOps environment lives in AWS, but where in AWS? So before we even got to that point, we had to define, how are we going to structure our resources within AWS? And part of that is, how do we set up the account structure so that we can deploy resources into accounts. We can manage our billing. We can manage how we understand where our costs are going. We can have
And securing it.
Security isolation between environments. So first off, we're thinking about, okay, so how do we need to set up AWS that we can then bootstrap a DevOps environment into it, and then from there bootstrap other environments like test and stage and production and so on. So the very first thing that we were thinking about is, what environments we're going to have, how are we going to need to structure our AWS organization in order to be able to cope with all of this. And so actually very simple, really, we just took best practice approach from AWS. Why wouldn't you? So we took security, the sort of security best practice around account structure. Take advantage of AWS organizations, have a master account, and then you have child accounts for every environment that you create. So the first bootstrap is create that organizational structure within AWS, set up all your accounts, set up all your billing, set up all your billing alerts, so you can keep control or at least visibility on costs. And then you have a structure in place that allows you then to start to think about, right, actually, I now need to build a DevOps environment. I now have my AWS DevOps account that's nicely isolated.
Yep.
And so then we would think about, right, okay, let's bootstrap the DevOps environment. So how do we do that? And so we use Spinnaker. But there's a number of parts to it, actually. So obviously we use GitHub.
Because again, even the DevOps environment has to start off as code.
Exactly. So we have its own repository within GitHub, which stores all of the DevOps environment artifacts. So we've automated the entire bootstrapping process, but it's manually kicked off. So at some point, you need to start. You've got nothing in the cloud. So how do I start? So we've created automated scripts but we manually kick them off because it's effectively bootstrapping your DevOps environment is sort of a one-off process, right? You still want it automated because if we ever needed to tear it down and rebuild it, we want to be able to do that quite quickly.
Yeah.
But fundamentally, it's sort of one of those environments that once you've got it running, you're probably unlikely to tear it down and recreate it. So that's so the first thing we do is we create the scripts to bootstrap the DevOps environment, and that involves in effect creating an EKS cluster with all the supporting resources in AWS. We use Terraform for that, and then we deploy Spinnaker. And then, as part of all of that, we use Cloudflare for a DDoS protection, for CDN support, and also web application firewall. But in effect, it controls our domain. And so we expose then Spinnaker through Cloudflare, but then hooked up by OAuth authentication into GitHub. So then we've got external. So every engineer should have access to Spinnaker to be able to see when deployments are succeeding or failing.
Yeah.
So this is all part of the sort of DevOps Bootstrap, is getting that environment running. And as I say, it's all scripted, it's all automated, but we just have some manual parts of the process where we have to kick it off. But in effect, then what we have is we have an AWS account structure in place, which supports us, organizationally from a billing perspective, so we can understand where costs are going. We now have a DevOps environment isolated within a single AWS account. We then have the ability now to be able to then create further environments within that whole structure from the DevOps platform. So the other thing that I haven't mentioned actually between all of that is CI. So we don't have like an on-premise or cloud-hosted CI like Jenkins, for example. So we don't run our own CI service. We actually make use of a publicly hosted CI service in Shippable. So other people might be using something like Circle or Travis. So we use Shippable, which is our sort of link between GitHub and then going into our continuous delivery process.
But again, going back to what the definition phase is, depending on what people were doing, then we might, we might be hooking into a different CI thing, or we might be spinning up a Jenkins instance on this DevOps cluster as well.
Absolutely. In fact, Spinnaker and Jenkins do work well together, but we haven't actually taken that approach, so we use Shippable. But
that's where Jenkins would live if you were putting it in here, isn't it?
That's where Jenkins would live as the CI service in effect, which you would then host yourself on your own, almost like on your own tin, but it could be cloud hosted. So at this point, we have DevOps, which allows us to then utilize that DevOps platform to deploy other infrastructure environments, but also to deploy microservices. We've actually got all the account structure in AWS to support those other environments. You can do you could do the same thing in Azure. I'm not an expert in Google Cloud Platform, but again, in terms of like the definition phase, you would have to discover, exactly if a client said, I want to use Google Cloud Platform, you'd have to look at, well, okay, so how do I do roughly what we're doing here with AWS? How do I sort of do that, taking into account best practice for that platform? How do I do that within the Google Cloud Platform? And also the cloud infrastructure itself. So Spinnaker for DevOps, it runs on Kubernetes cluster. So we treat Spinnaker almost as a set of microservices that run on Kubernetes, but that is our continuous delivery platform. So we're already at this point creating cloud infrastructure, which is quite good actually, because it keeps it quite consistent. It doesn't matter whether it's an app microservices platform or our DevOps microservices platform.
It's all behaving the same way and using the same.
All behaving the same way, using the same, monitoring software and so on.
Okay, so we've set up DevOps, and then we can start from there to. I mean, are we at the point yet where we're ready to sort of spin up some other environments?
We could be, yeah. So with the way the approach we took is that obviously get DevOps in place,
Yeah, get that in first.
get that in first. So at least to the point where you have CI working, because people can start building libraries, can start building services, and those services can be um, at least quality tested and built and
Yeah,
pushed to a container repository, container registry, which for us is held in our DevOps account in AWS. So all of our container registries are held there. So you could at least do the CI part of doing that quality testing, the analysis, the building of the program, the building of the container, and then registry or pushing that container to a registry. So that whole part can then be delivered. You don't need an environment. You don't need a test environment per se. At this point, you don't need a staging, and you certainly don't need production.
yeah.
So people can actually start from an application perspective can actually start to
They can
build
start doing. They can start doing some valuable stuff.
exactly.
Although this, although as episode one, which we'll talk about later, but that was all the login diagnostics. That's one of the things that we did first from the app team perspective, was they were getting all that kind of basic libraries in place. That because you end up at when you're delivering microservices, you don't just start each microservice and think, well, this is totally different from everything else. You start with generally one of the reasons why microservices you can deliver them really fast is that because you kind of deliver the first couple of them, and then you've solved a lot of the basic plumbing problems. The boilerplate code, and so the logging diagnostics, how you actually implement a REST API, how you do security, how you do and it's those things that you can kind of start getting people to do all those things that solve the problems that apply to every single microservice, so that then it's just all that's cookie cutter, and it's just what is the functionality then?
Absolutely. So you're absolutely right there. And we take the approach that all of our external dependencies, whether they are external services that we call or third-party libraries that we use, everything is abstracted behind effectively an interface. So it makes it very easy to mock, makes it very easy to test. But also, if those services that we depend on don't exist yet, we still can have a working quote service, but by running it in effectively in mock mode.
Mm-hmm.
So it's still valuable at this stage.
Yeah, and app developers that have been doing TDD or something like that would have been doing this for a long time.
Exactly. Yeah. 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 So with that, that's in effect what we do. So although we might not necessarily have an environment with all of the supporting infrastructure services that might be needed to do login and so on, we can we can still actually do useful things even in the absence of that from an app development perspective. But you're right, you need to get all the core the core
Yeah.
foundational services in place, even if they're running in mock mode.
Although having said that, we're going to talk about a lot of that a little bit later when we talk about the kind of the SDK sort of stuff.
Absolutely.
So we acknowledge that it's there, but basically your app team can once you've got your CI in place, the app team can start to do some useful stuff, and then we move on with the environments and start getting at least at least the first environments in place, so that the app guys can start have got somewhere to go. So so looking at environments, I mean we kind of take the approach of let's not overcomplicate things. So integration, which is obviously the main kind of integrated functional test. environment, and we've got staging, which is production-like environment, and then obviously production.
We also have performance, but we don't. They're not 24/7 running environments.
Yeah.
They're sort of on-demand environments, and again, this goes back. The beauty of automating everything is the fact that we can do this, right? So it doesn't. There's no lead time of weeks or months in order to put together a performance environment.
Yeah. So when you want to do a performance test, step one of performance test is spin up a performance environment. The last step of performance test is tear down the performance environment.
That's right, yeah. Assuming you've got all of your results off your machine you want. Yes, absolutely. So, for us to put, so there's obviously the definition of a performance environment. So, what shape does that performance environment take? And that obviously takes a bit of time. It's not like weeks, but it takes time to define what that performance environment looks like. But to actually then provision one, for us at the moment, we can easily provision an environment within 20 minutes. That's a full working environment.
Full scaled out.
Because it's and most of that is actually waiting for AWS to create the EKS cluster and the nodes. It's actually relatively quick as a fully scripted end-to-end process. 20 minutes max, pretty much, will get you an environment. And tear down, similar time. Again, it takes a while to tear down EKS and the nodes, but it's what I'm saying is that it's you're not talking weeks.
Yeah.
To produce a performance environment. Once you've got your shape, you're talking in the order of half an hour sort of lead time, which is a really, really nice place to be, because it means that we're fully in control of our costs as well at that point, because we can provision the performance environment on demand. We don't need it for any longer than we absolutely have to, and we can tear it down again and immediately reduce our costs.
Yeah. So that's performance. Obviously, production is a similar thing, except you don't tear it down. That you get the shape of the production environment, you spin it up, and typically then you're maintaining it, but you're not tearing it down, because you need to keep that there. So our integration environment, I mean, we talked about in the principles of DevOps, we talked about the immutable applications, and that really applied in
good memory.
Yeah. And that really applied in the integration environment. The fact that one of the other really good things about Kubernetes is the fact that you can effectively isolate your applications in it, so you can deploy multiple versions of the same microservice, but they can't see each other, and so you can spin those up, test them, tear them down again. But we tend to keep an integration environment around.
We do, yeah. So that environment stays. So does staging. Staging, in terms of the way we deployed staging, is just like we would deploy to production. So service by service, blue-green deployments, that sort of thing. Whereas integration testing environment, as you rightly pointed out, we deploy completely isolated applications for a test run. But again, on that single Kubernetes environment. So we're sort of really taking advantage of the density there. And overall, we try and control costs by utilizing AWS's spot instances as much as possible. So spot instances are really cool, actually. They're a discount on the sort of normal on-demand pricing for EC2 VMs, and they represent spare capacity that AWS have. But at any time, AWS can notify you to say, we need that capacity back. So you end up having a bit of a hybrid environment where you have a combination of sort of on-demand and spot instances. So you have a small on-demand group to allow you to migrate workloads over from your Spot instances to your on-demand group when AWS say we need your Spot instances. You've got a 2-minute window in which to move your workloads.
So
And
that's an interesting
all
one,
that
actually,
automated.
because I mean that's one of the things. It's like any, it's like any other thing where someone has provisioned a load of capacity and what the capacity that is spare gets sold off cheap. And the same thing happens with airlines.
Why have it running? Why have it sitting there doing nothing?
Yeah, the same thing happens with hotel rooms, and it happens with airline seats, and anything where the capacity is fixed and demand is variable.
Yeah.
You end up with excess capacity that you just want to get something back for. How often do they actually say we need this capacity back?
It's well, I mean, to be honest, it's very variable. So we've there are times when we've provisioned environments where we can't actually even get the capacity. So your Spot instance group won't even. So what happens? You get a Spot request, and there's no guarantee that that's actually going to be sort of accepted. Because also don't forget the spot price is variable, so it will sort of change. And what you do is you say, I would like to take, I want to put a spot request in for Spot instances, but I'm not willing to pay more than X for it. So you might set your limit on how much you're willing to pay for a Spot instance to say maybe, I don't know, let's say a third of the on-demand price. So that's your limit. So it might be that the price goes north of that, and you're no longer, your limit is gone. It's exceeded your limit, and you're going, well, actually, I don't really want to pay more than a third for it. So actually, take the Spot instances back. So it's not just necessarily a case of, do they need the capacity back? It's where does the price go as well.
So and this is and again looking at this from the perspective of if there was another client doing this, I mean this is a solution that we've got which people can pick up and use, which gives them lower infrastructure costs for their test environments. If they felt like no, I absolutely need that capacity, then okay, you can go to on-demand pricing, and you can guarantee that stuff's there, and it's going to cost you more, and it's just a question of your, it's a question of priority of, do you need that? Do you need that stuff now, and you're not worried about the money, or do you want to be a bit more thrifty, and you're prepared to that sometimes you're not going to get your spot price.
Yeah, absolutely. And so we like to be thrifty. So we like to keep a lid on the costs. So Spot instances are a really useful tool for us to be able to do that with AWS. So no, I don't know whether it's you're doing now, but they certainly never did. I don't know whether they do now. It's been a while since I've looked, but I think it's a fantastic feature that AWS offer. And why not? Even if it's reduced price, get rid of your spare capacity.
Yeah,
and get some money for it. So very clever.
Okay, so recapping on where we are after a little foray into cloud spot pricing,
cost management, which is part of the 7 outcomes.
Well, costs optimized. It's one of the outcomes, isn't it? So
exactly.
we're looking after your budget as well. So we've spun up our little DevOps environment. We've connected to our Git. We've connected up our CI. We've created environments where we're able to deliver integration staging, performance, production environments. These are all, and what we're talking about here is these are Kubernetes environments. So these are, these have got master nodes, they've got worker nodes, and depending on which cloud provider you want and what your constraints are, then they may be, those might be templated ourselves, or our solution is to use the master nodes using EKS in Amazon, because then that whole headache of maintaining the master nodes and making sure they're available is managed by Amazon. But there's an equivalent in Azure, there's an equivalent in Google Cloud Platform.
And you don't even need to use their hosted Kubernetes.
You don't.
Kubernetes services. You could use it yourself.
You could be using your own machine templates to do that.
Yeah.
But the principles are still the same. That effectively so we've got our DevOps cluster. That's its own little Kubernetes cluster. With in our instance, we've put Spinnaker on there, and Spinnaker will then will then spin up further Kubernetes clusters to do for the different environments. And so I think we've got to the point now where pretty much infrastructure from the point of view of we've got a Kubernetes service running is in place. But in terms of a microservices technology platform, we haven't gone as far yet as we'd want to do, because you've got a service onto which you can deploy containers. But one of the first things that we'd do as part of this is we would, going back to episode 1, logging and diagnostics, we'd say, well, actually, there's no point in having that, particularly, well, in all these environments, there's no point in having them if you don't know what on earth is going on. You can't have a production environment that you don't know whether it's available or not. There's no point in having a test environment if you can't diagnose faults. So the first thing we do is we put logging and diagnostics into it. And and we talked about that in episode 1. So Fluent Bit, which is a flavor of Fluent that is optimized for Kubernetes, and then we use effectively my mouse not working properly. The EFK stack for so Elasticsearch is a typical sync for all that data. Kibana as a way of visualizing it, and you can use those tools for alerts. We also use Prometheus for time series data and Grafana for visualizing it. So there's a whole rich kind of tool set out there for logging and diagnostics, and we've got this as a stack. So again, don't reinvent the wheel. We've got a logging and diagnostics stack that's based on industry standard EFK kind of thing. Just use it. Don't go don't go off at a tangent. We've got we've got a really good solution for that. It's described in full in episode 1. If you want to build your own, go and listen to episode 1. If you want to use ours, get in touch and we can talk through that and take you through what we've got. In particular, is there anything else on that kind of logging and diagnostics that we should kind of highlight?
Not massively, no. I think obviously it's very important. But we're not doing anything that isn't. So we've chosen a particular stack, but it's not like it's an unusual stack. It's not like it's not best practice. I think there's actually quite a lot of people probably doing the same thing. We use Fluent Bit. We instead of Logstash. But again, lots of people are picking the EFK instead of Elk. I think we're not doing anything completely bonkers. It's fairly standard, but it's a combination of tools that gives us a really rich view into what's going on within the cluster, which fundamentally is a bit black boxy, right? So you've got to use these tools in order to get that sort of to sort of open up that environment and see what's going on. So the only thing we don't have in there that we haven't mentioned is around like network tracing and so on. So we effectively on our Kubernetes clusters we use Istio for and it's sort of again it's starting fast becoming a sort of standard for having a service mesh on a microservices platform, which really controls the communication between microservices. It also controls communication in and out of the cluster, so ingress and egress. But along with that comes the ability to be able to also uh, understand what's going on at a network level. And so there's tools like, it automatically, integrates with things like Prometheus, but also Jaeger tracing and so on. So there's definitely, there's options in there as well. If you're using something like, Istio as a service mesh sort of infrastructure level service,
Yeah.
which we certainly recommend, because, from an app perspective, normally, in the old days, if you were writing web services, then your client code really needs to understand, because services fail, services become unavailable because they get overloaded. You need to be able to have those transient failures need to be retried. So you need to think about retry libraries, you need to think about circuit breakers, and so on. Whereas a service mesh provides all of that stuff out of the box through policy. So if it provides, at an infrastructure level that you can define policy for how services communicate with each other, and automatically get the service mesh to do the retries for you, you don't need to bloat your code.
Yeah. And so that again becomes part. So that again becomes part of our infrastructure fabric to say, because what we're doing at this point in this delivery part, we're putting in everything that the applications need, so that the app teams can build on them. So that kind of that that service mesh, that virtual network and all that sort of thing, is part of that that application kind of fundamental fabric that's going in. And I suppose the other thing that forms part of that fabric is your databases, isn't it?
Yeah. So
a database is part of an application, but a database technology is part of the fabric.
Yeah, and I think we talked about that a lot of these in episode 2, I think, wasn't it? NoSQL, yes, equal to NoSQL.
Yeah.
But fundamentally, yeah, there's the sort of shared infrastructure services that you might take advantage of. Most applications store data or work with data in some shape or form, and so identifying and then making available the sort of database technologies that work well within a cluster. So they work well in perspective of being able to have replicas that work on a consensus-based mechanism, that have auto repair, that can be scaled out across a cluster and so on. So we tend to sort of pick and choose particular technologies that work well with a cluster, that also then give us the style of data storage technology we want. So is that queuing? Is it storage? Is it graph or and so on?
And there's a lot of choice here. I mean, it's
there is a lot of choice. Yeah.
I mean, again, a couple of years ago, if you were to go around and say, I only want database technology that is supported by a Kubernetes cluster, you'd probably feel like you were having an uphill struggle. Now it's all the vendors, not all the vendors, but a lot of the vendors are falling over themselves to be Kubernetes friendly, aren't they?
I think it's I think because Kubernetes is becoming so popular. The container-based approaches to running services is becoming popular. Therefore, Kubernetes is that sort of natural extension of how do I run containers at scale? How do I manage containers in an environment? And so Kubernetes is the sort of natural extension to that. And it sort of is captured the mindset of pretty much anybody doing anything with containers.
Yeah.
To the detriment of other technologies that were doing a similar thing. And I think a lot of that's to do with the ecosystem. It's huge. And so therefore, if you're a database technology vendor, then you can't ignore it. You really can't. So, you have to think about how you're going to, how are you going to make your your technology work within a Kubernetes environment. So we won't even, because we're sort of both feet in with Kubernetes. So we don't.
We're all in.
We're all in. So we don't. We will absolutely look at the technologies that do work really well with it, and we just won't consider technologies that don't, because they end up being something that sort of has to exist. I mean, we're lucky. We're in that sort of that position where we can
we're sufficiently greenfield. We're sufficiently greenfield that we can make that choice.
We can make that choice. But otherwise, if you can't, then you've suddenly got this little bit of infrastructure on the side that you have to have in order to support your more sort of legacy, if you want to call it that, but legacy technology, because it might not work well with Kubernetes. So you've got to have some infrastructure on the side.
And there's ways around that.
You've got to support.
I mean, it's really great, the stuff we've got. So the likes of Elastic, the likes of we've got, on the NoSQL stuff we talked about on the NoSQL episode 2. We talked about a whole ton of this stuff. So ScyllaDB, even Elastic's really good. If you weren't using Scylla, you could, Mongo's quite well supported. A lot of the NoSQLs are really, really good in this area. The SQL vendors, maybe not as much so. And so if you were trying to lift and shift, if you had a load of services and you were trying to lift and shift them into microservices based on this kind of technology, you probably, it's the SQL stuff, relational databases that you might be thinking about a bit closer. And the cloud vendors have got databases as a service. You might want to look at that, because then that makes it kind of a lot easier to fit it into this.
And I think that is the approach. I think if you're going into this environment with cloud, and you've got a Kubernetes environment, but then you need to use a SQL technology that doesn't really fit. It makes a lot of sense to me to treat that as just an external service that you consume.
Yeah.
So you don't, from a perspective of dealing with the sort of administration or operational side of it, let somebody else deal with that. Let the cloud vendor do that, and just treat it as an external service that you want to consume. And so that for me makes a lot of sense, because otherwise you've got yet another bit of a bit of infrastructure on the side that's specialized to run that particular technology.
And then as time goes on, and this is the thing, that as time goes on, you end up with like a death by 1,000 cuts. If you try and replicate your old bad habits into your cloud environment, then once you're at your 20th microservice and they've all got some widget that is bespoke, then suddenly you're just back. You're back with half the headaches you had before.
Exactly. Take advantage of the fact that the cloud vendors, that's what you're paying for. Let somebody else take the headache of dealing with the operational overhead of managing these technologies, and you concentrate on your Kubernetes cluster. That makes a huge amount of sense to me, anyway.
Cool. So I think pretty much.
It's the delivery phase.
I think we've done the delivery phase. So yeah. So just quick recap over that. We've put the DevOps in place. The first thing we did was we singled out all the accounts. We created a DevOps account. We put all the DevOps infrastructure in there, and that account could then deploy environments into all the other ones. And then on those environments, we've put all the shared common services that you might want to use, such as the diagnostics, the logging, the dashboards, the alerting, the databases, the message, event bus like Kafka or whatever. And we're actually at a point now where we are ready. We are ready for the app teams to sort of, we can cut the ribbon, hand this over, and the app teams can actually start doing some stuff. So that's kind of a really, really, a really big milestone to go through. So let's see, where we've been going 1 hour and 10.
Yeah. So
how are you feeling, Paul?
Not too bad. I think we can. I think we can do it. So delivery is quite big though, isn't it? It's there's a lot of things to think about in there. Now the great thing is that you take advantage of people that have done it before. Then delivery doesn't become quite as scary as it might look on the outside if you've never done it. So but at this point, and and it's worth again saying, although we cut the ribbon on it, it's depending on how we deliver, how the implementation plan looks is to whether we've split delivery up into chunks. That means that we can move into the exploit phase in stages, in the way that we've delivered in stages. So, but yeah, at some point there's a cutting of the ribbon, which means that somebody can start to take advantage of what's happened within the delivery phase. Within delivering that technology platform. So I think we should plow on and.
Well, I think we should
about the exploit phase.
I think we need. Well, I think we should save exploit phase for another episode because actually there's a lot to talk about with exploit. So on that bombshell.
Yeah, I've been overruled.
On that, because that's why
you're the CEO and I'm not.
Yeah. On that bombshell, so yeah, we've gone on quite a journey. So delivering a microservices platform based on Kubernetes. We've decided how we're going to do it. We've looked at we've done the blueprint. We've delivered the environments, and we've got to the point where your app teams can cut the ribbon on it, and that is an amazing journey. And if you want that, talk to us. Yeah, you can go to the 345 website, book a call with us, and we can just chat about it on the phone and see what you want to do. No obligation. Just we're here. We're lonely. Well, not really lonely. we're all in the same room, but you can chat to us. You can chat to us. Just book a call through the website and chat to us, and talk about what your ideas are, and we'll talk a bit about what we've done, and you might get something out of it. So that would be great. So thanks everyone for listening, and we will catch you in the next episode with how to exploit your Kubernetes microservices platform. So we'll catch you then. Thanks a lot. Bye now.
Bye.